Hello everyone, welcome back to another video. In this video, we are going through Browse from Hack the Box, which is a media machine. We found a web portal on port 80 running Chrome extension uploader. We noticed that Chrome is launching for each extension upload, and once running, it also interact with the internal port 5000 and browse internal.htb domain. That gives us access to internal path, which eventually reveals TTL instance with public backup repository containing source code of that Flash application. So by uploading the malicious extension and attempting SSRF through that, it lead us to reach the port 5000 and then exploiting the internal application with bash arithmetical injection that allowed command injection of the server, giving us shellless Larry. So after that, a quick sudo -l reveals a path to privilege escalation, and by abusing a world-writable PyCache, we finally escalated to root. So this machine is a great example of how multiple small weaknesses can be chained together into a full compromise. So let's get started. Starting with Nmap with -hc to enable script, sv to enumerate version, and saving output in all format in a Nmap directory as browsed and IPS 11.127. So this would usually take a time, so we had already ran it. Alright, while going through the output, we can see there are two ports open, port 22 and port 80, both representing that the Ubuntu server has been used. And we have OpenSSH and Nginx running on port 80. And the title and nothing much. So let's go through the site. Let's try to access the site. Let me copy this again. New instance. All right. Okay, since we have a domain and some sort of browser extension handler, maybe. Let's see if we have anything in source code. Let's not select anything. We have two more options as well. Not to select anything. Alright, nothing here. Let's explore the option we have. So this is an upload extension which let us upload the Chrome extension, and our developer will use it and reach back with some feedback. So basically some interaction is going on. Hopefully Chrome extension is being installed on this. All right. So let's explore the sample page as well. We have three different framework and sample of this framework, Chrome extension framework. So let's download one of this. Let's see what we have here. It looks like typical example of a Chrome extension. Let's copy this. Let's move this to our folder. Okay. Yeah, let me unzip this. All right. Okay. Alright, I unzip here only. All that, let me create folder and on everything into that. All right, let's look into the files. The main file is the main manifest.json that represents like which version has been used and pages it would be using, and you can also see the extension would be running the content.js on all the URL the browser websites. So meaning if we go through any page, some random page, that JavaScript would be run by the extension that we would provide, and it would be running in all the URLs. And this is the content.json, nothing special here. And let's see, let's try to upload the sample file on the portal and let's see what we'll get back. Let me do this. Works. Send this to developer. Taking some time, so that's a good thing. That means the extension is either being installed or taken care by the server. Let's see what we have. So it feels like, yeah, the Chrome is being used, and based on the directory, based on the directory, it seems it's running on the sandbox, but not it's not running on the sandbox, but on the local machine in itself. So let's confirm that before we move ahead. Yes, it's definitely running on the machine, not on the sandbox environment. Let's go ahead and see if we get our extension installed on this. Okay, it seems like the browser is hitting the local host and browsed internal.hexthebox. So we now have a two domain. So let's add that onto our host file. Go out of the IP. And all right, and we browse.hexthebox. Let's add this and VPC. Yeah. Let me check if I spelled it right, just in case. I did. All right, let's visit the site. Okay. All right, so it's on Gidia instant. That is okay. Nothing. I can't scroll anything. Let's see. Let's explore. So there is a public Markdown preview, maybe. So Larry has published a Markdown preview publicly in this GTA instance, and let's see what this app is all about. If we have any source code for this Chrome extension, let's see. Let's go through the app. So it's a Flash-based application. We have submit file. Okay, that is used to render an HTML. Okay, saves the file. There is routines. Script manages the routine, run the bash script with no shell. Okay, so basically the application has this routine API kind of thing, a page, and that is calling, or that is taking any input without any sanitization, directly passing into the script. So this could be a potential command injection we could test for if we get the access of this Flash application, and it looks like it is running on localhost port 5000. So now probably we have an idea of what to do with the Chrome extension. Let's see the routine script as well. All right, so the argument is compared with either 0, 1, 2, 3. So they are expecting a numerical value, but no sanitization check is there either in the script or on the application itself. And based on this, there is an attack called bash arithmetical injection, I think. Let me matic injection. Yeah. Okay, let's see if this is what we are looking for. Yeah, there you go. This is what we were looking for. So any variable or any argument that is passed with IQ or like equal to indication without any sanitization check, I think we can send the argument as array, and in that we can pass command of our choosing, like this. Yeah, so this would convert this as an array, and the $sign would help us to execute the command of our choice. So basically allowing us and command execution through routine. So now we have an idea of how to exploit this localhost, but now the thing is how to reach the local 5000 port, assuming the Flash application is running on that port. Okay, keep going on to our output from this extension, just in case if you have anything else. And the extension has not been installed, then I think we might have to look into other areas, but it is getting installed. This is not our extension ID. This is basically loading of an existing extension in the Chromium or the Chrome headless environment. Localhost S2. So we can use this, probably this Chrome extension or the Chrome headless environment to hit the localhost port 5000. And yeah, this is it. This is what we were looking for. We got our extension ID, and basically this is the extension that we uploaded being installed, and JavaScript being executed probably. Let's see. Yeah, anything else? All right. Let's go back to our content.js. So what we'll do, we'll use the same sample. Yeah, we'll use the same sample, just uploading the content.js with our malicious JavaScript and try to execute the command, or let's try to reach to the internal server. But even before that, let's make sure that this is working properly. So let's use the JavaScript. Let's try to get some hitbacks. What is the IP config? Okay, so we'll make the JavaScript run on all the URL and ping us back. All right, and let's await it to fetch the URL. That should do it. Let me see. Yeah, that should do it. So let's test this out. Let's see if we could get anything back onto our server. Let's first start and keep the server, if I could type right. Alright, while this is running, let's I think R, not R, I think then, oh, it's -u update. So let's update our file. I'm already here. Context, not, let's update context.string and context. Oh, okay. Maybe it's supposed to give the sub file first, and then like the way we are using. Alright, it did add our file, and let's try to upload that. Let me close this. Let's try to upload Chrome extension. This should be getting us a callback, but it didn't. So let's see if it installed the extension or not. It did install. Why didn't come back? Alright, let's see. Did we saved it? Okay, we did not. We did not. It didn't updated the version we wanted it to update. Let me cross out this again. Alright, it's updated here. Alright, I think -u is not the right. Let's try check again. And updating content. Let's see if we got right this time. We're dead. This is what we wanted. And let's go back. Okay. Alright, now things should be working as we are expecting it to. Let's upload the extension again. Let's see. we did got ping back. Yeah, only one hit is there. So basically that confirms that the browser is hitting our URL. Let's see the logs as well. There should be the extension being installed. Here is the extension. All right, there you go. Now we are sure that the browser is running our JavaScript, the malicious JavaScript that we want. Now let's try to hit internal Flash application on port 5000 with routine, I guess, routines with the ID. Alright, so let's see first what is the safest ID that we can use. Is temporary file cleanup. We can use this. So let's try that first. Okay, let's go and 5000. Well, what we'll do, let's try to run the command directly of using the bash arithmetical injection. Okay, let's update our function then. Let's make this an IP. That's what our attacker IP. Let's give them port as well. Let's try to get shell directly on 80. Let's create command or shell bar. That's the 9. TCP and then IP port and let's do one. Yeah. Let's use this. Okay. Alright, let's create a payload after this. So now this is where the bash arithmetical injection would came into the place. So let's say we want our URL to hit this routines. I'll confirm that before sending, and this should be attemptably encoded. That should be calculating encode URI if I'm not wrong on the component key of assign our payload here. And let's make this nothing. We should be calibrate this. Now this should be it. Let me search for the arithmetical injection as well. Just confirm what how it used. Gosh. Like but let's see. And maybe this is not okay though. We want the payload. There you go. This is what we wanted. Just to make sure. Let's go here. Instead of running ID, we would be echoing the command. Let's add this command and make this in bash. This should, let's change this to like this. So it did execute this. I'll change all this as well. Alright, let's try to run this first and see if we could retract from the server. So I did wrongly. IP code and let's maybe I'm doing something wrong here. Alright, let's give us the IP complete
Here's 1589. Close this. 89 on the should allow us to get ourselves a shell. Close that as well. Let's get shell here. So we'll use RL wrap with netkit LUNV. We are listening to port 80 here, and we should get a shell back with this. If not, then I think we'll try to change this into bash and then try to send that way. We are encoding here, but this might look weird. So this is how this would look. The command would be here, and all of this would be URL encoded. So we'll see if this would help us to get the shell. All right, let's upload our extension. Okay, just taking a bit. Okay, we didn't get our shell back. Let's see what. Come on, URL hit. Okay, so this is extension. It didn't. It's not hitting back. Let's see if we could find. If we could find the URL. We can't. Maybe it didn't upload it here. Let's see. Let's confirm. JavaScript is right. It is right. Let's see what. Oh, we didn't call the. Oh, that is a bit dumb of me. We didn't fetch the URL that would actually head. Alright. Now this should complete the function. Hopefully. If I'm not doing any obvious mistakes again. Let's try to upload the extension again. Alright, it's loading. It did ended up. Let's confirm if we hit. We did hit, but we are not hitting on right port. So again, like I said, obvious mistakes. Alright, meanwhile, let's confirm the use of this as well. So it is encoding rightly. Let's try to upload it again. Alright. Let's save this. Start this. And let's upload the extension again. Let's see if we could get it. If we didn't get this time, I think I'll try encoding all of this in bash and then echoing back to not bash base 64 and then echoing back to decode it. Alright, it did finished. But it's making call now, but no code execution. So let's try to JS has a function called BTOA, I guess. That it is what called. Confirm it. Yeah. BTOA. Let's encode all of this as base 64. I'm then trying to read. And base not bash 64 have to be. So this should help. Everything should be fine now, and we should get ourselves a shell. Let's see. Maybe not. But we didn't get anything back. See. Let's see if I spelled routine correctly. If not, then yeah, I did. Yeah. And it is encoding. So this is right. Let's see. Let's try to. It's still sending our payload and It's not dash. But then I saved it, right? Yeah, but then add that. All right, let's do this again. Maybe third time is charm. Okay, let's see. And we got ourselves a shell with Larry. So yes, everything works fine. So with BTO and with this, we get ourselves a shell. Alright, we got ourselves a shell pack on this. Alright, let's see. Now we are Larry. And let's try to get a L. Alright, there is an extension tool which has sudo permission attached to it. Let's first try to get user Larry user.txt. Yeah, we could get the user file. So that successfully get ourselves a user shell as Larry on the box. And now we have potential path to root in this extension tool. So let's go here first. Extension tool. Alright, so we can see. Alright, so this is interesting. We can see an extension directory, PyCache directory, two different script tools and utilities. Now let's try to see the command of tool. Alright. So as you can see, the extension tool is importing extension util, and we also have worldwide permission on PyCache, basically allowing us to tamper with the bytecode of Python that is compiling. So here all the if a tool is being executing, if a script is being executed, Python script, and is importing a different extension or a different Python script, the Python would compile this, paste the bytecode in the PyCache, and then load the binary to the script. So with this, it is easy. The script does not have to compile the different scripts again and again, different modules again and again. That way it keeps a cache of those modules, compiled script basically, and then run it again, use it basically back to back. And so if we had this access to the directory, we can try to attempt I think PyCache poison attack. Let's see. PyCache. So let's see. View a different sample of this. Yeah. This is explaining, I think, which blog I refer to. I think, yeah, this was the blog that I referred to initially while doing the box. So this is basically this blog post will go through you explaining what this vulnerability is and how to locally escalate our privileges. The basic all of this lies on to us having permission of PyCache, and once we have that, we could update the bytecode, and Python would trust the bytecode, but in only one condition, where it matches the header data. I think it is not showing the header. Let's see if this is it. So basically, the script, the compiled PYC code, bytecode, has the magic bytes in this format. The 0 to the first would indicate the version, the other would indicate the bit like fields in which format the code is in, a timestamp based, hash based, or hash based checked, unchecked. So these are the new, but these are not default by default only timestamp is being used, has been validated, and this is what we are looking for: the source timestamp field and source file size. So in our case, basically, the code would have the timestamp of this util script and the size of the script as well. So any bytecode that has the file, this metadata, the file size and timestamp, the Python would trust that bytecode based on whatever the content is. So this is the vulnerability. This is what we'll be exploiting, and we'll try to attempt privilege escalation through this. So let's see how we could do this. Let's follow this. Yeah, let's follow this only. This is what I did initially. It's go through the exploitation steps. So let's import this into let's put gtem directory exploit go to be exploit echo this to our shell.py. Let's see. Then I think I might have copied it wrong. Let's try to remember. I forgot about it. That would mess up my shell. Alright, let's get our shell back. Let's see. Alright. And let's go back to exploit. Remove this. Let's see if we have this. Not what we want. No, let's remove this as well. Let's get the script again. Cool. Oh, that is why I been enrolled. All right. Now we have this. What is the next step? I think compiling with compile module. All right, let's try this. Compile file on shell.py and this should give us primary of this. Let's see. Malicious Bytecode. Now we have to update the file like this Bytecode metadata with the file size and timestamp of the victim, or not victim, but the targeted shell's Python script instead of shell.py. So for that, the blog post go through one of the script as well that takes the second script, the original script, and our malicious bytecode, and then it would need the second script bytecode as well. We'll execute. We'll run the script in sudo first. Then it will create this code, bytecode automatically for us. So this is not there yet, but we'll get that. It fetches this file, and you can see it updates it get the state of the original script, and update the size to this code. There you go. Updating keeping the flag, the first floor 4 flag as it is, and updating with the timestamp and the size. So we could directly use this. Let's first edit in. It's a bit hard to edit here. So let's get this sorted out. What was that? To high sample. Yeah. No. Attention to beauty. So let's copy this. We'll paste this cut here. And one more thing, like we discussed, that should be in Bytecode or extension util here as well. If not, yeah, we need to run the script. Think let's read it. First, we need a extension that won't change anything. So this takes few arguments, and there is a clean argument. This is what we wanted: temporary. Let's clean up the temporary files, so it won't need much. Select run like that. Team, and that should get the extension util here. So this is what we want. Copy this. Let's paste it here. And instead of exploit, let's put the shell and temp exploit. Let's exploit, right? Yeah, exploit, and then here, so giving the access to shell, and this should be util. All right, so this should do it. This should, this should update the existing util bytecode with our shell code. And let's name this on.py. Alright, let's go back. Run Python TP P, and let's exploit the get P. What was my IP? And team 3 on the PL. All that. Let's confirm we have the right file. We do. Let's run this. But before that, let's confirm if we have anything to do. So it says the same thing that we have to run the Python script. First Python script as sudo, and then we will fix the part. Right, let's run this. Alright, it says the metadata has been poisoned. Let's run our sudo extension clean, and this should get ourselves compile. Let's see if we root, what was it? Root bash. We do have it sticky permission at, so this is ourselves getting root permission. Alrighty, we are root, and we could get the root flag as well. So this was the box for you. If you like this video, please like, share and subscribe. See you in the next one.